Tonight is Christmas Eve. While we speak, legend says that an elderly, overweight man dressed in red velvet is piloting a wooden vehicle pulled by flying animals. To a child, this is magic. To a physicist, this is a crime. If we apply the strict laws of Newtonian physics to the legend of Santa Claus, the result is not ho ho ho. The result is a fireball, sonic shockwaves, and instantly vaporized reindeer. But what if we've been using the wrong physics all along? In this special Christmas episode of Discoverix, we're not just going to say Santa is impossible. We're going to try to save him. We'll use Einstein's relativity, quantum mechanics, and even string theory to prove that maybe the impossible is just an engineering problem. Get ready, we're about to calculate the science of Christmas. Let's start with the cold hard numbers. There are about 2 billion children on Earth. But let's be generous and only count children who celebrate Christmas. That leaves roughly 378 million children. If we assume an average of 3.5 children per household, Santa must visit 91.8 million homes. He does have one advantage: time zones. By traveling east to west following Earth's rotation, Santa gains time. Instead of 24 hours, he has about 31 hours of total darkness to work with. Sounds like a lot? Let's do the math. 91.8 million stops in 31 hours means Santa must complete 822.6 visits per second. Think about that. In one single second he parks, goes down the chimney, eats the cookies, delivers the presents, climbs back up, and flies to the next house. 800 times. To do this, assuming an average distance of 1.2 kilometers between homes, the sleigh must travel at 1,050 kilometers per second. That's 3,000 times the speed of sound. For comparison, the fastest spacecraft ever built, the Parker Solar Probe, doesn't even come close. And now, the real problems begin. When you run on the beach, you feel wind on your face. When you travel at 1,000 kilometers per second, that wind becomes a solid wall of air molecules. At this speed, air resistance is catastrophic. The sleigh wouldn't slice through the air, it would collide with oxygen and nitrogen molecules so violently that it would generate heat comparable to nuclear fusion. Let's talk about the reindeer. The two in front, Dasher and Dancer, would absorb 14.3 quintillion joules of energy per second. In practical terms, they would burst into flames instantly, vaporizing the entire sleigh behind them in 4 milliseconds. Santa wouldn't even have time to blink. And even if Santa had a vibranium heat shield, there's still G-force. Accelerating from 0 to 1,000 kilometers in a blink would generate 17,500 Gs. A fighter pilot blacks out at 9 Gs. At 17,500 Gs, Santa's 120-kilogram body would be slammed into the sleigh seat with the force of 2 million kilograms. He wouldn't be crushed, he would become red jelly. Classical physics has killed Santa. End of story. Not quite. Because classical physics breaks down at extreme speeds, we need to call in Albert Einstein. A theory proposed by Dr. Katie Sheen from the University of Exeter uses special relativity to save Christmas. If Santa travels even faster, say 99.99% the speed of light, things get strange. First, he becomes invisible. Due to the Doppler effect, the light reflected off Santa would be compressed into such high frequencies that it would leave the visible spectrum and turn into gamma rays. That's why you never see Santa. He's moving too fast for the human eye. Santa Claus changing size. Lorentz contraction states that objects traveling near the speed of light shrink in the direction of motion. That solves the chimney problem. At high speed, Santa and his massive gift bag become paper thin, slipping through any opening effortlessly. And most importantly, time dilation. For us on Earth, the night lasts only a few hours. But inside the sleigh, traveling at 99.9% the speed of light, time slows down dramatically. Santa could have months or even years inside the sleigh to deliver presents calmly while only minutes pass for us. But there's still a problem. Reaching the speed of light requires infinite energy. So maybe the answer isn't speed, maybe it's location. What if Santa isn't a person but a particle? Physicist Dr. Larry Silverberg proposes the theory of relativity clouds. In quantum mechanics, a particle can exist in multiple places at once in a state of superposition until it is observed. Maybe Santa doesn't travel from house to house. Maybe on Christmas Eve, he enters a state of macroscopic quantum superposition. He is in every chimney at the same time. He delivers 91 million presents instantly. This explains why children are forbidden from trying to see him. If a child observes Santa, the wave function collapses. He is forced to exist in only one place, ruining Christmas for the other 91 million children. So the rule, go to sleep and don't peek, isn't about behavior. It's a quantum safety protocol to maintain superposition. Wormholes? Time dilation? Quantum superposition? It sounds insane, but these are real theories we use to explain the universe. If an advanced civilization visited Earth today, their technology would look like magic to us. Maybe Santa Claus is simply the greatest engineer who ever lived. So if you hear something on the roof tonight, don't look. Don't collapse the wave function. Let physics do its job. This was Discoverix. A quantum Merry Christmas to all of you.